Welcome to my online course in linear algebra for undergraduate mathematics. Today we are going to discuss examples on rank and nullity of linear transformation. In my last lecture, we have discussed definition and theorem on rank and nullity of linear transformation. Today we are going to discuss example. First example is let T from R3 to R3 be linear transformation defined by T x y z is equal to x dex, y dex, z dex, where x dex is equal to x, y dex is equal to 2y, z dex is equal to x plus y plus z. Find the rank of the linear transformation. First, write what is given. Here t x y z, the linear transformation is given. That is t x y z is equal to x to 2y x plus y plus z. We know the standard basis of R3 is 1 0 0 0 1 0 0 0 1. Put the element 1 0 0 in this linear transformation. We will get the t image, that is t of 1 0 0 will be 1 0. Put the value of y equal to 0. Then 1 plus 0 plus 0, that is 1 0 1. Again, t image of the second element of the standard basis of R3, that is 0 1 0. Put the value of x equal to 0, y equal to 1. Here x is 0 and z is 0, y is 1. So this is t image of 0 1 0 will be 0 2 1. Again, t image of 0 0 1 will be equal to 0. This is 0, this is 1. As t is linear transformation, so the set of t image will generate my range space RT. Next, this B will be basis if anyhow we show that these elements are linearly independent, for which we consider any three scalars ABC such that linear combination of these scalars with the vectors of B is equal to 0. That is, this linear combination is 0. A into 1 0 1 plus B into 0 2 1 plus C into 0 0 1 is equal to 0 0 0. After simplification, secure both the left hand side and right hand side, we will get this equation, that is A is 0, B is 0. Then put the value of ABC in the third equation, we will get C equal to 0. That means our B is linearly independent. B generate range space and B is linearly independent by the theorem in the linear independence and linearly dependent set. This B is my basis. Now rank of T is equal to dimension of range space RT, that is number of element in P, that is my dimension of rank space. Rank of T is my 3. Now from the theorem, rank of T plus nullity of T is equal to time of P. So put the value here, time of P is 3 and rank of T is 3. Put the value, I will get nullity of T is equal to 0. That means my null space is consists of only 0 elements. 0 element. Next question, a linear transformation y equal to ax which carries e1 into y1 equal to 1 2 3 dex and e2 into y2 equal to 3 1 2 dex and e3 into y3 equal to 2 1 3 dex. Here dex denote this is not a row vector, this is column vector. This is column vector. Write the equation of the transformation. We have to find out equation of the linear transformation. Then find the image of the vector x1 given by this 1 1 1 dex vector and x2 equal to 3 1 4 dex vector, 4 dex, and x3 equal to 4 4 0 5 dex, so that x1 and x2 is linearly independent, so is their images. Let T be the linear transformation. Here U1, E2, E3 are the element in the basis of the in the standard basis of R3. Given T1 0 0 is my 1 2 3 and T0 1 0 is 3 1 2 and T0 0, 1 is my 2, 1, 3. This. Let xyz be any point in R3, then xyz can be expressed as the linear combination of this basis element, element of the standard basis, that is xyz is equal to x1 0 0 plus y 0 0 1 plus z 0 0 1. Since T is my linear transformation, T x y z, take the T image in both the side of this equation, I will get T x y z is equal to T of this equation. That is x T 1 0 0 plus y T 0 1 0 plus z T 0 0 1. Now put the value of T image of the basis element, that is T1 0 is this, T0 1 0, T0 1 0 is this one, and T0 0 1 is my this one. Put this value and simplify, I will get this equation, that is x plus 2 3y plus 2z comma 2x plus y plus z 3x plus 2y plus 3z, which is the required linear transformation. Now find out the T image of x1. Here x1 is my given, x1 is 1 1 1, x2 is 3 minus 1 4, and x3 is 4 0 5. So find out the T image of this x1 x2 x3, where my linear transformation is this one. So put the value of 1 1 1, T image of 1 1 1 will be 1 plus 3 plus 2, that is my 6, then again 2 into 1 plus 1 plus 1, that is my 4, 3 into 1 plus 2 plus 3, that is my 3 into 1 is 3, 2 into 1 is 2, and 3 into 1 is 3, that is 3 plus 2 plus 3 is my 8. T image of 1 1 1 is my 6 4 8. Likewise, T image of 3 minus 1 4 is my 8 9 19. T image of 4 0 5 will be my 14 13 27. Next, we will show that this vector x1 and x2 is linearly independent. For that, consider A and B be two scalars such that linear combination of A with vector x1 plus B with vector x2 is equal to 0 vector. Now put the value of x1 and x2. We will get A 1 1 1 plus B 3 minus 1 4, which is equal to 0 vector. Simplify, we will get a plus 3b, a minus b, a plus 4b is equal to 0 0 0. Equating the left and right side, we will get this equation, which is as the right hand side are 0. So this represents the system of homogeneous equation. Now solve this system of homogeneous equation. Uh, First, find out the coefficient matrix. Write the coefficient matrix. Then find out the rank of the coefficient matrix by echelon form. So this is the coefficient matrix. Matrix obtained by the coefficient of AB in all the three equations. Then find out the rank by echelon method. That is, first make this element 1. Here it is already 1. So make all the remaining element below this column 0. So this is equal to 0. Make this 0 with the help of proper row transformation. Okay. Next, make this element 1. Then with the help of proper row transformation, make all the element below this 0. So finally, here after calculation, I have found rank of matrix A is equal to 2, and which is equal to number of variable. Here I have not shown the calculation, as you have already studied the method of solving homogeneous linear equation in your first semester. So I am leaving this for your own practice. If you have any problem, you can discuss with me. Since the rank of A is equal to number of variables. So the system of equation are consistent and it has unique solutions, and that unique solution is my a is equal to 0, b is equal to 0. Therefore, the vector x1 and x2 are linearly independent. Again, we shall show that the t image of x1 and t image of x2 are linearly independent. For that, we consider two vector alpha and beta such that linear combination of alpha with t image of x1 plus beta t image of x2 is equal to my 0. Put the value of t image of x1, t image of x2, which we have already calculated here. So put this value here, that is 648. The image of x2 is 8, 9, 19. Then simplify, we will get these equations. That is 6 alpha plus 8 beta, 4 alpha plus 9 beta, 8 alpha plus 19 beta is equal to 0, 0, 0. That is 0 vector of R3. So equating the left and right hand side, we will get 3 equations in 2 unknowns. Here the right hand side are all 0, so this system of equation represent a homogeneous linear equation. So solve this by solving by using the method of solving homogeneous linear equation. First write the coefficient matrix. This is the coefficient matrix obtained from the coefficient of the unknown in the all the given equation. Then make the pivot element. First element is 1. Then make all the remaining element below this column is 0. That is, make this 0 with the help of upper row transformation. Then move diagonally, make this element 1 and make all the remaining element below this column 0. That is, make this 0. Then number of non-zero rows will be your rank. That is, rank of A here is 1 non-zero rows, 2 non-zero rows, third row is of 0 rows, so which is equal to number of variable. Therefore, the system of equation are consistent and it has one unique solution, that is alpha is equal to 0, beta equal to 0. That means t image of x1 and t image of x2 are also linearly independent. So we get our answer here. Next question. Let t from R3 to R3 be linear transformation given as t of x1, x2, x3 is equal to x1 minus x2 plus 2 of x3 to x1 plus x3, x2 minus x3 minus x1 minus 2x2. Find the kernel of linear transformation. Answer, we consider x1, x2, x3 belongs to null space of T, linear transformation T. If this element belongs to the null space of T, then T image of this element is my 0 vector. That is T x1, x2, x3 is equal to 0, 0, 0. Now from the definition of linear transformation, T of x1, x2, x3 is equal to my this one. That means this is equal to my 0 vector. Now equate both the right and left hand side, we will get this three equation. x1 minus x2 plus 2x3 is equal to 0. 2x1 plus x2 minus x3 is equal to 0. x1 minus 2x2 is equal to 0. Since the right hand side of the equation are 0, so this system of equation will represent a homogeneous linear equation. So solve this system of equation by the method of solving homogeneous linear equation. First find out the coefficient matrix. Here coefficient of x1, x2, x3 in first equation is 1 minus 1, 2. In second it is 2, 1 minus 1. In third it is 1 minus 2 and 0. Then with the help of echelon form, find out the rank of this matrix, coefficient matrix here, which is my 3, which is equal to number of variable. As the system of equations are consistent and there is one unique pair of solution, that is x1 is equal to 0, x2 is equal to 0, x3 is equal to 0. Therefore, x1, x2, x3 is my 0 vector. That means NT, the null space consists of only 0 vector. These are your home assignment. You should solve this home assignment. In case of any problem, any doubt, any difficulty, any query, you should ask me. I will solve it for you. With that, I would like to conclude. Remaining will be in the next lecture.